we have learned about many definitions about rational number and irrational number. It would be quite useful if you are thorough with that. You know that a rational number is of the form p by q, and the denominator q should not be equal to 0. It should be other than 0, any value, isn't it? Because if it is 0, we won't get value. It will become the infinite value then. That is why the condition is the denominator should not be equal to 0. And an irrational number, it should be a number that, because it is a number that cannot be expressed as a fraction for any integer. That is, it cannot be expressed in the form of p by q. It cannot be expressed in the form of p by q. That is why we call it as an irrational number. And what is called the co-prime numbers? See, two numbers that do not have any common factor other than 1. For example, you can take 35 and 39. You can see the factors of 35 are 1 into 5 into 7. So these are the factors of 35. Similarly, the factors of 39 are 1, 3 and 13. You can see that there is no common factors between 35 and 39 except 1. So that type of numbers are called the co-prime numbers. So you can say that 35 and 39 are co-prime numbers. So we get into the question now. So we are going to prove that root 5 is irrational. So first of all, to prove it as irrational, we are going to assume a contradictory way that we will consider that root 5 is a rational number. So that we can take that root 5 is equal to a by b, that is a rational number. And b is not equal to 0. Suppose if a and b have a common factor other than 1, then we divide by the common factor to its lowest term, so that a and b are co-primes. That is, for example, if a by b is of the form 4 by 6, isn't it? We have the common term 2, that is, it can be divisible by 2. So 2 2s are 4 and 2 3s are 6. So its lowest term will be 2 by 3. The same way, if a and b have any common divisors, that is a common factor, we can reduce it to the lowest terms, and we can see that 2 and 3 are the co-primes. They don't have any other factors common, isn't it? So this kind of values are called co-primes. So this is how we are converting to co-primes. The numbers we are converting to co-primes. Then we can write root 5 equal to a by b. Because we have considered root 5 as a rational number, we are writing root 5 equal to a by b, and we shift this b to the left side. The division becomes multiplication, and we square both sides. We get b root 5 whole square equal to a square. After squaring, the root gets removed. We get 5b square equal to a square. So we can say that a square is divisible by 5. So by theorem 1.3, we can say a is also divisible by 5. Now let us take a is equal to 5c for some integer. That is, we are taking the value of a is equal to 5c, and c is some integer. Substituting the value of a, we get, so we are substituting the value of a equal to 5c in this equation, and instead of here we put 5c here. So after squaring we get 25c square. So we can cancel 5 both sides. After cancelling we get b square equal to 5c square. So it means b square is divisible by 5. So we can say b is divisible by 5. So we can say 5 is a common factor of a and b. I have assumed that a and b are co-primes which doesn't have any common factor, and we have proved that phi is having a common factor. Phi is a common factor of both a and b. So this has become a contradiction. So we conclude that root phi is irrational number. Hope you enjoyed the class. Thank you.